Hi folks, we're going to take a look at page 3787A, and in this question here they're asking us to find the points of inflection of this function. Okay, so we're going to have to determine when the second derivative is equal to 0 and then see if there's a change in sign for concavity. Okay, so let's start by finding the derivative here. Now first of all, let's just take a quick look at the domain of this function since there's a logarithm involved. But since x is being squared means we can have negative numbers. So the only restriction here is x can't be 0. And we have that restriction both from the numerator because of the logarithm and the denominator because you'd be dividing by 0. Okay, so we now know that everything other than 0 is fair game. Okay, so let's find the derivative. So use the quotient rule. So first find the derivative of ln x squared. So 1 over x squared times the derivative of 2x. And then multiply it by the denominator, so x, and then minus the numerator function, ln x squared, times derivative denominator, which is just 1. Okay, and all divided by x squared. So before we go on, let's simplify. So we have x squared and x squared, which cancel out. So we're left with 2 minus ln of x squared over x squared. Okay, so let's go ahead and find the second derivative now. Okay, because that's as simple as we can get it. So find the derivative denominator, so it's just a constant. So we have negative, well we already found the derivative of ln of x squared, so I'll just copy that. So 1 over x squared times 2x and times the denominator function, which is x squared. Okay, minus, now we've got 2 minus ln x squared and then times the derivative of the denominator, which is 2x. Okay, all over now x to the 4th. Okay, so let's simplify here. So we have x squared and x squared. That cancels out. So here we've got negative 2x. Okay, and so here we've got 2x times 2, so minus 4x. And then here we've got negative 2x times ln x squared times negative ln x squared, so plus 2x ln x squared. Okay, and all over x to the 4th. Okay, notice here that, well, we can simplify this. So negative 6x plus 2x ln x squared. And lastly, we have a common factor of 2x in both terms in the numerator. So we got 2x, and here we're left with negative 3 plus ln of x squared. And we can cancel out. There we go. End up with this as the second derivative. Okay, so once we've actually done the simplification, it's not quite so bad. Okay, so we have to determine is when the second derivative is equal to 0. Okay, and so here we need negative 3 plus ln x squared to be equal to 0. So ln x squared has to be equal to 3. Okay, now remember that the natural logarithm is a logarithm to the base e. So this can be written as e cubed is equal to x squared. Okay, so x is equal to square root of e cubed. Okay, or we can just write that as e to the 3 over 2. Okay, either way. And so now we need to determine whether this, be careful here because we're taking the square root, so plus or minus e to the 3 over 2. Okay, there's two possible answers here, and what we have to check is whether this relates to a point of inflection. Okay, so I'm going to test that here. Now you have to be careful because even though we're only testing these x values to see whether they're points of inflections, I'm also going to include 0 here, okay, just so that I can carefully choose the numbers, okay, to test for my intervals. Because here, don't forget that the sign could conceivably change at 0, okay? So if I pick a number in this interval, that won't necessarily work for that right-handed one. Now, to help me test this, I'm going to just get a sense of what e to the 3 halves is, so I can choose the right numbers. Okay, so e to the 3 over 2. Okay, and that's about 4.5. Okay, so we have negative 4.5 and positive 4.5. Okay, so let's take a look at the second derivative. Okay, so here if we take, say, x equals negative 5, we notice that the denominator is going to be negative. Okay, so denominator is going to be negative because it's x cubed, so we just have to check the numerator. Okay, so here we have negative 3 plus ln of negative 5 squared, okay, which is a positive number. So positive over negative, so it's negative here. Okay, let's pick something like negative 1 in this interval here to see what's going on. So again, the denominator will be negative, and let's see what's happening with the numerator. We can probably figure that out here because we have negative 3 plus ln of negative 1 squared, so ln of 1, which is just 0, so that's going to be negative over negative. So here we have positive. Okay, let's choose x equals 1, and that's going to be very similar, except here the denominator 1 cubed will be positive this time, and here similarly negative 3 plus ln 1 squared, so negative 3 plus ln of 1, so that's 0, so that's again negative. So here we have negative, and now let's pick something like 5. Okay, so the denominator will be positive. Okay, and the numerator, well, it should give us the same as before, but let's just check it. Negative 3 plus ln of 25. Okay, which again is positive. Okay, so the result is positive. So we see here that we have a point of inflection at x equals negative 4.5, and we also have a point of inflection at x equals 4.5. Okay, so I'll leave that up to you to take these numbers and input them into the equation, or actually, you know what, why don't I just do that? So let's find the y values. So now, since I'm actually being asked for the points, I'm going to give exact answers. So the y value at, say, e to the 3 halves, okay, so that's equal to ln of e to the 3 halves squared over e to the 3 halves, okay, so that's equal to, well, this is just going to be ln of e cubed over e to the 3 halves, and ln of 3 cubed, well, that's just equal to 3 because the natural logarithm and e to the x are inverse functions, so that just gives me 3 over e to the 3 halves, okay, and then y to the negative e to the 3 halves will be very similar, okay, because we see that the numerator is essentially going to be exactly the same thing because I'm just going to be squaring this, so it'll become positive, so I know the numerator will be, excuse me, 3, and then my x value is negative e to the 3 halves, okay, so basically we have negative 3 over e to the 3 halves, and I'd be happy for you to leave it like this, okay, so just a quick recap, okay, as I try to pan out so that we can get a view. There we go. So there's a view of the full solution. So first thing we did was we found the first derivative, then found the second derivative. From there, solve for when the second derivative is equal to 0, and then we determined the sign to see if there were sign changes. And here we had 2 points of inflection. Okay, that is it.